We start now with a new topic of trigonometry, which is about right triangles. We're given angles and or sides and try to find the other angles and or sides. We start, however, by looking at some old things or things that will become useful. And the first thing to look at is the Pythagoras. If we have a triangle, then Pythagoras says that if the angle gamma here is a right angle, then c squared equals a squared plus b squared. You see that this arrow is looking on both sides. What does the arrow to the right imply? If the triangle is right angled, then c squared equals a squared plus b squared. What does the left arrow mean? It says that also the opposite conclusion is correct. This means if c squared is equal to a squared plus b squared, then the gamma is 90 degrees. Let us now look at two examples in 3D. And the first one is given a cuboid and quadrant with sides A, B, and C. We want to find out how long is the length of the diagonal of the cuboid, the Körperdiagonale. We see that the two angles shown here are both right angles. And we start by looking at the triangle ABD. I've resketched it here on the right. And since there is a right angle here, we see that the Pythagoras applies, so d squared is equal to a squared plus b squared. The small d is hereby the diagonal of the rectangle in the base plane, in the Grundebene. Now let us look at this triangle with small d, small c, and capital D. It is again right angled. Again, the Pythagoras applies, so capital D squared is small d squared plus c squared. Calling the equation here on the left, d squared equals a squared plus b squared star, we get by inserting now the star into our upper equation, d squared equals a squared plus b squared plus c squared, or d equals the square root of a squared plus b squared plus c squared, which is the formula how to find the diagonal and space. In example 2, we look at a pyramid with square base, with base edge length s being 7 meters and height of the pyramid h being 11 meters. Please ignore the small triangle, it shouldn't be here. We want to find the length of the slant edge L, and we want to find also the surface area of the pyramid, which means the base face plus 4 times this triangle here. To find the area of the triangle, we need the length of the base side, which is just S, and the altitude HA of this triangle. Let us start by having a look at this triangle here that is right angled. I have copied it over here, and its sides are HA, the hypotenuse. This side here is H, the height of the pyramid, and this side here is just half the length of the base edge. So we can use the Pythagoras, and we get HA squared is H squared plus S squared quarter. And for the area of the triangle, we get it is 1/2 times S times HA, which is equal to 1/2 times S times the square root of H squared plus S squared quarter. And so we get for the total surface, base face plus 4 times the area of the triangle, so S squared plus 4 times this here, and we get in the end, when we insert the numbers, approximately 210.6 meters squared. To solve the second task, namely to find the length L here of the slant edge, we could use this triangle here, but we will use instead this triangle here. The triangle is right angled, so I copied it over to here, and we see the hypotenuse is this slant edge L, this side is HA, and the base is again half the length of the base side, so as half. And we get, again using Pythagoras, L squared is HA squared plus S half squared. We can insert now the formula from before, number 1 here, And we get that L squared is h squared plus s squared half, and so we get for L approximately 12.1 meters.